to dragonflies, which is probably not surprising to anybody based on what I'm wearing today. What we call odonates is often a term to encompass dragonflies, damselflies, and an extra weird group that are in the order Odonata and insects. And so they can be really, really colorful, as you can see with this array of just like different colors and shapes and sizes in them. And so in the adults, we tend to see these insects with long, slender bodies, long wings, really, really big eyes. They've got spiny legs, and they're often lots of different colors. But what most people don't know is that they spend most of their life underwater, so they're aquatic insects, and they tend to be a lot more cryptically colored. They don't yet have their wings, they're actually kind of growing folded up on their back, and they can also be in a wide variety of shapes and sizes. And so kind of a common thing when I have conversations with people asking me questions is they'll say they saw a dragonfly, and they'll start describing it, and it's very clear that they're referring to a damselfly. And in some places, the words can be really interchangeable, but for people that study them, we think of them very distinctly. And so kind of the general rules when we're looking at them is we see these larger eyes that are either touching or close to touching in dragonflies. They tend to be more robust. Their wings are kind of always outstretched, like the ones on my back. Damselflies tend to be a lot more slender. They have kind of eyes separated, kind of more like a hammerhead shark. They're objectively cuter in my opinion. And their wings are almost always kind of held above their body at rest. There's a few groups that decide to hold them out in damselflies, but most of them are not. And then we have this weird little group called the dragon damsels. There's only 3 species still living today. They all live in Asia, but they're called the dragon damsels. They're a weird little group. They're like kind of have the bodies of dragonflies and the wing shape of them, but hold them like damselfly wings. Their eyes are more like damselfly like spacing, and they're just a really weird group, but they exist. And so dragonflies are incredibly successful predators when it comes to the literature of capture success and their ability to catch their prey. Dragonflies are empirically the most successful on the planet, with 3 different species listed here, reaching up to 97% success rate in capturing their prey. And so they're really good, and they're also predators in the water. And so in the water, dragonflies employ both of our kind of broad predator strategies. And so their larval stages have this unique adaptation called the labial mask, which is basically a modified lower lip that it shoots out to grab onto prey. These can be shaped really, really differently. So we can get really flat ones with just hooks at the ends to grab onto things. We can have more scoop-shaped ones to kind of surround small things. And damselflies have them as well. So yeah, just look at there's a lot of weird variation we can get. And so we'll have a couple of the larval stage of this in the museum in a few minutes for you to see as well. And so the adults will also do this in dragonflies. So we get both the sit and wait and the active predation. The active ones tend to be kind of constantly flying around and looking for their prey. So the really big ones that you'll see kind of in swarms in the sky are kind of always on foraging trips. And I couldn't get my sit and wait videos to load, but if you come see me in the museum, I could pull some of them up for you. Damselflies are also really good predators. They're a little bit less directly studied than dragonflies, but they only employ that sit and wait strategy. So they kind of will sit atop things that they'll perch on, and they'll fly out to hunt prey. And they'll do that in kind of 2 ways. So here's an American ruby spot dragonfly at Peter Creek. It's kind of missing here, but it's flying off to grab that, and then returning right to its perch. There's not any good videos of the other mode that they get, but those are what we call the gleaners that will fly off from a perch and they'll pluck things off of the ground. So you can imagine kind of scenes from fantasy of just like this huge monster coming down to pick something up from the ground. It's kind of what the insects that they eat have to fear every day. Like Em mentioned, things that don't have venom tend to use some kind of spine or spiky projection to catch their prey, and that's exactly what dragonflies do. So they don't have any venom or toxins, and so instead they employ these rows of spurs that they have on each of their legs. There's kind of 2 rows on each one, and they use those to capture their prey. And so here's kind of a close-up of one in flight trying to catch a mosquito. And so kind of my research actually looks at those characters, and so here's a CT scan of the leg of a dragonfly, and you can see just like how pronounced those spurs are. And those tend to be on kind of the equivalent of our forearm in the leg segment of those dragonflies. And so they can eat a wide variety of insects. For a long time, we kind of considered them just generalists and just eating kind of anything in the sky. And that can be the case for some of them, but in most cases, they'll specialize in prey size. So you'll have a lot of them that kind of really focus in on either super, super small things or pretty big things, kind of something in the middle. Again, without having any venom, they need a little bit more than just the ability to hold on once they get something to actually catch it. And so they've got a few other tricks up their sleeve, which includes their incredible vision. They have the largest compound eyes of any insects, with 30,000 simple eyes within each eye. And the kind of largest of their eyes gives them almost 360 degrees of vision, so they can see lots of different places. They're also really, really sensitive to aspects of light. And so the wavelengths of light that kind of the blue sky gives us is really, really bright for them. So if you can think of any like media where you've got like this bright light, this like kind of special figure comes out of it, that's kind of what every single insect in the sky looks like to them. So it's really, really easy for them to find them and latch onto them. When we combine that with their flight ability that they get from having a special ability to manipulate every single one of their wings independently and kind of twist them in lots of different ways, that makes them some of the best flyers in the insect world as well. So it lets them basically manipulate how they want to flap each one of their wings, lets them fly in basically every single direction, kind of up, down, and backwards. Yeah, so they can fly in a lot of funky different directions and things like that. And so kind of the combination of those spurs, but their vision and their flight really help them to capture a ton of variety of insects across the world, despite being a pretty small group of insects relatively. And sometimes they get overzealous and will try to hunt birds as well. They only succeed with hummingbirds, but they get a little big for their britches. And so kind of the last question, now that we've talked about predators and how they hunt things, is just kind of the brief question of how do insects avoid getting eaten? For predators, missing a meal or two isn't the end of the world. They can try again next time. But if you're being hunted, once they get you, it's kind of the end of the line. So there's a lot more motivation to not die than there is to kill something else. And so there's lots of cool different anti-predator defenses that organisms will employ. Behavioral defenses, like either swarming together to scare predators, kind of trying to dodge them really well, or kind of hurting and things like that. Playing dead is another thing that we see in a lot of different organisms. Then there's things like warning coloration, where bright colors tends to kind of be associated with like really toxic compounds in some capacity. There are also things that will try to look like other things that are really toxic. And lastly, you can also just try to blend in completely, like the stick insects that just try to look like they're part of the tree, so nothing will try to eat them. And if you're curious about more like moth and butterfly related defenses, Jeff and Greg will be in the museum to talk to you about some of those. And there's a lot of cool ones that they do. So, I think that's it for us. So.
Yeah, so if y'all have any questions,